testing of security. And for this purpose, we'll listen to Mr. Frank Poignée, who is going to talk about best test practices for cybersecurity. I should briefly like to introduce Mr. Poignée to you. He studied computer science at the Technical University of Würzburg. He is ISQB certified tester and a safety engineer by the TÜV Rhineland. In his company called Infoteam Software AG, he is the consultant safety chief engineer and is also the project manager for functionally secure projects in automation and medical engineering. Mr. Poignée, the floor is to you. Yes, I should like to say thank you for the highly interesting discussions that we had over dinner last night. Well, discussions, languages, that's what I want to start with. We're talking about security or safety. In German, there's only one term, Sicherheit, meaning both safety and security in English. And functional safety, is, for example, was mentioned before. And if you add an attribute, what am I talking about? In English, it's easier. I have the term security and the term safety. Brief explanation. Safety means I have to keep the environment and people protected of what a system can do. So I need actions in order to minimize risks or be able to cope with them, risks that are generated by my system. The term security then says, also I have to protect my system from us, from human beings, from people. If you just remember the news, I mean, this is a fantastic idea for this kind of presentation here, where criminal energy is used to hack into a system. Whereas before in automation it wasn't all that easy because every system was an island, was insulated and encapsulated. But now, during the innovation, Internet of Things, etc., more and more areas of attack are being generated because if I want to have my wireless LAN available everywhere, I may not know that on that very same node there are data for control purposes, and some clever people could try and use this data for things that they weren't intended to be used for. So I need to protect the system from what we people can think up in order to compromise these kind of systems. When it comes to the normative side or legislation, we have different standards depending on whether I'm talking about safety or security. Here, this is the 61508. That's the safety definition by way of the V model. And I should like to show you how, during the development of a system, in which places, by what measures, what methods, the topic of security can be addressed. So I'm in a safety development process, and I want to also address security at the same time, because both things should be addressed at the same time in order to save cost and effort, to be as efficient as possible, and in order to make things possible in the first place. Because once my development has progressed very far, and then later on I'll find it hard to do something with respect to security if I didn't include that in the first place. Because very often I can't interfere with my system anymore. You know that from your development environment, you were talking about cycles that involves a lot of time and cost and resources, and we want to avoid this. So one possible way how we can do this in this development cycle is to be addressing security testing permanently. Where does it start? Where does testing start? Let's take a look at development. Well, most of you in the V model would point to the right-hand side, but that's too late. Your development needs to start here right at the beginning, at the very first step that you do in development and engineering. And you have to think and do something in order to look at testing for safety and also testing for security. One possible way of getting to this topic is a standard which deals with security that comes from the 27K series, and it says at the beginning of an analysis you can look at the requirements. We are doing this anyway from the safety aspect, because the 26.2 or the business 61508, these are requirement-driven processes. So in their very core, this is about requirements. And if I do the same thing, if I take this as a yardstick, if I'm in the requirement analysis phase, I can actually look at my methods in order to show where do I have possibilities to get security requirements. There's an entire set of methods, the ones that we are using mostly or that we prefer in our practical application, depending on what the circumstances are. You can take look at different things, but we are using Square. Squares was developed by Carnegie and Mello, and it is about definitions of target level of trust and certain processes and procedures that Square does model in order to win requirements from that, to gain requirements from that. And once I've got my requirements and I address security and I deal with this requirement just in the same way as with my safety requirements and my functional requirements, if I develop it accordingly, then a large part of security has been taken into consideration right from the beginning. So right at the very start of development in the requirement phase, this is where security has to start. And this is where it's also most effective. Another possible way of doing it is a little bit later in the process. Once I've had my requirements and I try to develop an architecture that cover those requirements, and then look at threat modeling. Maybe you've heard the term. Threat modeling means that the security architecture to be eroded, to be thinking about what kind of action could actually compromise my system if they were to attack it. So I generate threat models. That's something that's rather simple because I can work step by step in this threat modeling process. I do the composition of my system. I classify modules. So exactly the same technology that I use in development is nothing new. I don't need fantastic new engineers in order to be doing this. All I have to do is have a different focus. Normally, if I look at decomposition, if I have functional decomposition, and now I'm looking at security, and do the same things. I develop models, and by way of these models, I try and find out, is my architecture good enough already? And yesterday, in the discussion, it came out that one of the important points in the future will be to come up with good architectures. Everything that comes downstream will be suffering if my architecture hasn't incorporated the correct actions. And so anything that has to do with testing, to shift this to the right side of the V model, that would be wrong. You would have to start on the left-hand side with testing. The benefits, in particular when it comes to threat modeling, also before with the Square methods, the benefit is that I'm in a very early stage of development. I've not yet spent too many and wasted too much time and resources. I can still respond without having to throw away too many things that I've done already. I'm at the beginning of my development cycle. And this is also when it comes to the cost side, this produces the least cost also. If now you're looking at safety and security, this phase will extend, become a little bit longer, but in total, you gain at the end what you're losing at the front. The drawback is there are some people who rely on this. They say, okay, I've done everything in the early phases, I've developed good threat models, but unfortunately that doesn't mean that now you've developed good software. If you've developed threat models for your software, and you can make some statements about this, but you should then analyze these outcomes, these results, and take the corresponding action. Just to say, okay, I've done it, is simply not good enough. Once you've designed this phase and you've left that phase, you go into implementation. A proven action is to do static code analysis. Static code analysis maybe are done by manual reviews in many cases. I say maybe because the tools are available for this. The tools that are more or less available, are getting better and better to do this in a more automated way. And if I forgot something during my development process, if I selected the wrong buffer size, etc., if I just check my data, just assuming that they will be correct anyway, this is something that somebody who is trained and reads this code will understand this and say, okay, in the meantime, there are already tools that can detect this. And that can take a lot of the work off your hands. But you will not be able to do without any experts there. You have to use experts anyway in order to review the code, because machines won't detect everything. We have very highly creative developers who are leaving a backdoor open because some way, I'll do a commissioning process and I normally tend to have this and that problem, and then we'll come back to security, because these backdoors is not just something that the developer has available, but attackers can use them as well. And if you put these backdoors into a manual, print the master password for the control system in the manual and forget to change it, then you mustn't be surprised. These backdoors are very wide open to attacks. So static analysis as a tool, fantastic thing, because I look at every line of my code. I'm entirely complete with what I'm doing. If I have trained and very good people, this will be rather quick. They just read it through, make their comments, hand it over to the developer, and the developer will have to rework his code. The drawback, however, is I need these highly trained experts as reviewers. I need a high skill set. I need to be able to understand it, not just understand the language of the line of code. I must understand what it will do. I must have understood the specification. And in this entire domain that I'm working in, I need to be an expert in this entire domain. Another drawback is when it comes to these reviews, one only tends to do this for the new code, for whatever reason. But you tend to use libraries that you already have and that are older. And nobody looked at those older libraries. And this is where you have the problem sitting very often more than in the new code. The new code has been reviewed, it's okay, and then I use an Ethernet stack, and then you have a problem. So the drawback of the static code analysis, if you do your reviews, is you only tend to look at the new codes, the new bits of codes. It's a static analysis, so you're only doing it without the system up and running. So you have only a certain class of errors that you can detect, or bugs that you can detect. And if you were to go through a regression test, so if at some stage you actually need to do a loop, the backward loop in this development process, then you have to have then you'll have a lot of effort. So you have to do it manually then. So as I was saying before, there's better automatic code analyzers, which slowly but surely they're getting to a quality level that you will actually win something, gain something for safety and security. In safety, I can actually use it for my documents for certification to a certain extent. If I let some people sort of look over them, and in order to be able to make some changes manually later on, if necessary. But the problem is I'm still static. Moving over to dynamic security testing. And in the dynamic case, I try for my system to be penetrated by whatever kind of mechanism, to do something with my system in order to get it to produce bugs or find backdoors that are open, or to exploit something where designer or developers more or less consciously haven't thought. Well, in penetration testing, there's quite a lot of it happening. But of course, the drawback in Germany and Austria, for example, is that you're standing, you're in conflict with the law, with one leg that you're standing on, because you have to do this on behalf of someone. I mustn't say, well, I'll just try and see whether the telecom has an unsecure system and I'll try and penetrate their telecom system. No, you need the telecom commissioning you to do this. You have to agree on what you are allowed to do and when you're doing it, and if you do something bad in inverted commas, how bad may it be in a maximum case situation. And when it comes to the legality of something, I mean, this is a good source also to take a look at what the DSI says. The BSI, that's something, that's a government organization, but which will tell me what can I do legally speaking. BSI actually goes further. They define a process. And the BSI, not many people know this, have produce their own suite for penetration testing, and they're updating this suite. This is the state of the art of February 2016, and there were thousands of possibilities where I can actually subject my system to a penetration test with. So this is something that is this suite actually includes and takes up any attacks that have happened in the past, checking their own suite with respect to are there any backdoors or any vulnerabilities in my system, and that's the drawback of this penetration testing. Well, let me stay with the advantages first. Penetration testing, I have a suite, so I can actually get it to run very fast, easy, it's cheap, it runs very quickly. I don't need many highly skilled experts in order to get good results. And I test the one code which will later be executed, which is also something that I might not have with the other methods. When it comes to the static code analysis, I maybe read some code, but I'm not sure whether it actually is executed. And this afternoon, there'll be a presentation where code coverage will possibly also come up. So it's not for nothing that you have to think about this sort of thing, because there's many millions of lines of codes, and does it actually only have included in it what I actually need for execution? Does it have unnecessary stuff? Does it have any burden that might open backdoors, etc.? So I want to look at my release-generated code that's ready for execution. The drawback, the disadvantage is, well, I'm too far with my development. If now something is uncovered, then I have to start, depending on what it is, I have to start to go back to the requirements, if need be, in order to include new requirements. So in order to be able to implement them into this new architecture. And then in my implementation part, I mean, in the V model, maybe I have to go through the entire left side of the V. The developers are happy about this because very often, intuitively, the next they want to have something that they've done before in order to redo it and make it better. But those who have to pay the developer, or those who are waiting for something for this product to be handed over to the customer, they're not happy about it. So this penetration testing is unfortunately rather late. It comes rather late, and it turns your system into a kind of black box. So basically, you're frontally attacking your system. You don't go to the sophisticated areas of your system when you do penetration testing. So once someone has actually hacked your system, and then this is uncovered, then of course you're vulnerable there. And WannaCry is maybe a good example for this. The methods that that's been mentioned several times, it's fuzzing, tries to find these problems that aren't known. Whether the zero-day attacks that nobody has thought about yet, would my system be compromised by that as well? And fuzzing is the technology of choice there. There are two categories. Recursive fuzzing, I'll explain in a minute what it actually means in detail, and the second is replacive fuzzing. Recursive fuzzing is rather straightforward. I have a place where I have a data interface somewhere, and all sorts of combinations of input data are sent to that interface. So if I know the alphabet that is possible there, I'll just try out all the possible combinations. It's a total possibility, but after this, I know that my system was unable to be compromised. It takes a lot of time, unless you have the possibility in the certain environment with a high performance and maybe with a corresponding number of your test systems to do things in parallel. So it'll take some time. This is being done because it's rather straightforward, but again, there are limits to it as well. If you have a simple password query, just do all the possible combinations, even if it every 5 seconds, every 5 trials, 5 seconds are waited, etc., until you've sorted out the 20-digit password. That takes a lot of time, but technically speaking, it's possible. Replacive fuzzing. The door is meant to be used in an intelligent way. So when it comes to the password, to use things there to which the normal user would not be thinking of as using it as a password. You put this into so-called fuzz vectors. So I have different attacks that I subject the system to. Some of the categories are quite known to you. This is not for completeness. I took the most popular one, cross-site scripting, for example. That is to say, normally the developer or designer is expected to say, I enter a text that represents the name or my password, and rather than this, I put a script into this input line, and then I see what the system will do with it. What's very popular as an interface to such system, HTML is being used at the moment. I can work with a browser. I have a standardization there. I can use different tools to pass what has been standardized with HTML before, and I win, again, a lot of development time if I attach myself to such a standard. The drawback, of course, is that HTML is a very powerful business. Many people actually do think what it contains. And this fast scripting is just, cross-site scripting is just a minor thing. So with cross-site scripting, you could actually go and try to find out whether you can actually run the system as a non-administrator by way of these HTML properties. Well, buffer overflow. Why do developers do this all the time? Why can't they think about, not to put too many data into it? But they're just looking one way. They're thinking, okay, let's put 1,000 or 2,000 characteristics. This is what he's got in mind, and he doesn't think of it could be more. Or you have two developers. One of them sets the limit, and the other one is just meant to use what he finds. That's the example. And you can actually take a look at it later on. What was the part of the code review? You get a classical buffer overflow if you have two developers, and when it comes to the specification and the communication side, they don't exchange enough data. So unfortunately, in many software parts, you still have buffer overflows that are able to compromise such a system. I can infiltrate it with code and then fill in something that should actually contain data. Integer overflow is something similar. I think normally I have an entry in a certain value range, but I forget that this value range can be exceeded by the person inputting it, entering it. I used max or min, but max int or min int, but it's an integer. So I have an integer as a proxy. I have defined a certain data type, and for this data type, I defined limits. And when it comes to testing, I stick to these limits. And if I do fuzzing, then the data type is not of interest to me, but I try to get out of these data type limits and compromise it from the outside. Format string error is something similar. This is about strings. Somebody who has understood some programming languages, which are very often used with such cryptical signs in embedded systems, format indications for text outputs, then you know if you've made a mistake there once, then something comes out that I didn't want to see, or nothing will come out at the end at all. This is inherent in most of the programming languages. Also, when it comes to modern new languages, I've got format instructions. I can use them for attacking. Rather, instead of password, I just put such a format string into the system and let the HTML browser respond to it. You can try out if you want to log on to email box. To your email, you can enter such a string and you can see what happens. SQL injection. I can infiltrate in the one hand by way of trying to retrieve information. That's the passive side. I tried, and the active one is I try to inject changes. Both things are bad, and you should actually protect your data from this kind of attack. Possibility by way of protocols. I use LDAP as an example only. That I can attach myself to some sort of information. As a user, I never thought of somebody using the LDAP string to attach themselves to my information, but the browsers make it possible. XML instead of HTML, that's another big topic. XML requires XML parsers, which tries to evaluate this language so that I can use it in my program. And then there's a more popular, and that's XPath, highly popular, where by way of an XPath parser, I get my text structured by this XPath parser. And then it's possible that the browser works without a memory, has this XML tree in its memory for a very short period of time. And if you can actually access this memory, then I can actually make changes there. XML injection, more or less the same thing. Here I'm trying by way of XML language, means to do something what my browser understands and will do for me, and the developer never thought about switching it off. The benefits of these fuzzing technologies or techniques are very great. I actually get things which were not known beforehand, so I can actually get the zero-day vulnerabilities. Also, because I've not looked at the structure of my system, and I'm using not just old experience, but try to use intelligent automatic system in order to make it more automatic. And all of these automatic systems, they keep learning, so I can enter new things for testing. So fuzzing is a fantastic technology, but of course it has disadvantages. That is to keep this fuzzer intelligent. And almost everybody who does automation this day and age tries not to just map things that are known, but everything else as well. And this is a high effort, a great effort, because it's too late as well, because I'm rather at the end of my development process. If I find something, then it becomes very expensive. And this is what keeps some of the customers from using fuzzing extensively at the end of the process. So, what I need is do my security testing. I need to do my security, address my security by way of actions right from the beginning, across the entire life cycle. If I want to put safety, if I want to put up safety, I can do security in parallel. I can do it in one go because both have the same objective. Both want to keep the number of weak spots in my system as low as absolutely possible, minimize them, and I can actually do this in order to save time and resources. And this brings me to save some time as well. I hope I was able to make up for some time again. I went through it rather quickly. Thank you very much for your attention. Very well, Mr. Poignée. Thank you very much. This is a subject which sounds like it's a major effort. strenuous. That's my impression. Any questions here shortly before lunch? I'm keeping you from your lunch. Well, if there isn't any questions coming from the audience, I'll have one for you. Once I've done all of this that you've been saying, I mean, it's very cumbersome. Once I've done all this, then at the end of the day, can I feel good and say, okay, that was it for this project? I've done everything I could, and this was it for me. No, unfortunately, you can't do that, because in the V model, I've just looked at it up to the top, or the top bit when it comes to maintenance and system life cycle hasn't been talked about. And there are many clever people who keep identifying new backdoors. And I have to go about that again. So the standards say that it's an iterative or cyclical model. And unfortunately, you will never get into a situation where you can put your feet up and say, okay, that was it. We don't need to do any more. You have to do something about it all the time. Okay, thank you very much.